let's talk about polarization and color. We're not going to take these too terribly in depth. Just kind of, I want you to know some of the basic theories. Now, let me find my mouse here. Okay, there it is. Polarization of light waves. Now, most light is just going out in all sorts of directions. All right? This is unpolarized. Now, it's possible to separate the rays that are going in a particular direction. And this is called linear polarization, when we can separate waves with vertical oscillations from waves with horizontal oscillations. Think of a picket fence. Suppose I have all of the rays coming out, and they're going in all kinds of directions, but the only ones that can go through are those that can go through these vertical lines. Then we're going to wind up with a wave that is all vertical. While suppose we have rays coming in all sorts of different directions to this horizontal picket fence, then the only ones that are going to come through are, of course, horizontal waves. While if we have one vertical and one horizontal, we'll see that we're going to block all wave motion. Now, linear polarization can occur in two ways. All right, the first way is what we just described. We have a situation where only certain light waves can pass through, be it vertically or horizontally. And then these are going to be parallel to the transmission axis of our polarizer. Another way is polarization by reflection. Okay, that's when light hits a certain angle off a surface, and then the light is polarized parallel to the surface. All right, this is what happens when you hit at low angles on roads, bodies of waters, car hoods, etc. Now, for the most part, all light is non-polarized, so this is why polarized sunglasses work. They can cut out quite a bit of the light and glare from the sun. Now, color is very fascinating. The color of an object is just what it just depends upon the wavelengths of light that are reflected. So your red shirt reflects red wavelengths, and all of the other wavelengths are absorbed. So my red pen here reflects red. Everything else is absorbed. And a green leaf in white light reflects green, while all of the other colors are absorbed. Now remember, white is what happens when all colors get reflected. So white is actually the presence of all the colors, while black, you see black when all the colors are absorbed and nothing gets reflected. So black is actually the absence of colors. So what do you think happens when you have a green leaf in red light? Well, the green leaf is going to only reflect green wavelengths. In red light, you're only going to have red wavelengths. And so your leaf is actually, and this is kind of cool, it's actually going to wind up looking, you guessed it, black. Because black is when all colors are absorbed and nothing gets reflected.